Let's talk about lighting inside Unreal Engine 5. For that, we will build up the lighting for the basic scene that is provided in both stationary or more baked form as well as a fully dynamic form using Lumen. First off, let's take a look at the scene. By default, you won't see anything if you're inside the lit view, but we can switch to the unlit view using Alt and 3 or the button inside the viewport up top here. We can see that there is this small seaside town that has this exterior environment, as well as some interior rooms, including this apartment and the stairs that lead up to it. If we jump in game right now, we will see that we have this character that has a light attached that can be toggled with E. This is just so that you can run around and see what's going on in the scene without adding in any extra lighting and content beforehand. But to get going, let's actually make a copy of this map. So instead of modifying the demonstration map directly, which is inside the Seaside Town maps folder, let's make our own general maps folder inside the content folder directly. Maps folder. And I'll drag a copy of the demonstration map inside our own maps folder. Next, let's rename this to demonstration BL for baked lighting. Let's make sure we save it and let's open it up. This will provide us with a copy of the scene, and we can modify and edit all the lighting here that we want without having to separate it out to a standalone level. It might be a good idea to separate out the lighting, but because we have these very different two approaches that we want to follow, it is probably better to keep it as a separate level instead. So let's start adding in all of the basic lighting elements. For that, we can add them from the Place Actors menu or the Place Actors drop-down here, or we can use the new built-in tools inside Unreal Engine 5. And that specific tool is the Environment Light Mixer, which we can access from the window menu there. Let's create the skylight, the atmospheric light. Also, I can now go back to the lit view so we can actually see what's going on. Let's also create the volumetric clouds, and let's also create the height fog. So these are the basic elements that you would need to build like a basic outdoor lighting scenario. Let's filter down the outliner to the specific actors we are interested in. For that, I will just filter them using the light keyword as well as the fog and cloud keywords. This kind of advanced searching is available in several of the editors inside Unreal. For example, the Word Outliner as well as the Content Browser. That has even more interesting options when it comes to filtering. But right now we only care about the specific light actors in the scene, so let's continue with those. So we added in all of these elements. Let me hide them again and re-enable them one by one so we can go over their basic properties. Let's start with direction light. So direction light is a light source that's infinitely far away. So all the light rays become parallel, and also the shadow is projected from essentially an orthographic view. So the basic properties that this directional light has are its intensity, its color, what angle of it is, does it use temperature, and if you actually want it to affect the world and cast shadows. The intensity is pretty self-explanatory. It means how intense the light source is. The source angle defines how soft or sharp the shadows are. Depending on the type of shadow rendering that you use, you might not see this change here. Because we are using virtual shadows, we can actually see that the shadows are softened also while the light itself is not baked. But there are some specific variables that need to be considered when you actually want the light source or the shadows for the light source to appear soft or not. This also affects the specular highlight shape. The source soft angle is more interesting for just affecting the specular highlight size, but as changing this separately is not a very physically plausible approach. I'll leave that alone. When it comes to temperature, it means that you can actually define the color of the light via temperature. This behaves very similarly when you think about calibrating your display. So right now the temperature is 6500 kelvins. So this is like a very neutral white tone. And when I bring this temperature down, it lowers the temperature value, which represents the color output of a black body. And if that black body's temperature is lower, it will glow orangish and reddish. And when the temperature of it gets higher, it will start glowing more in the blue end of the spectrum. One other thing that you definitely do want to consider is if you actually do want to cast shadows. Right now, if I disable it, it looks very bad. But in some instances, especially if you are working on lower end platforms like mobile, you might want to consider disabling the casting of shadows or playing around with some other settings. So let's actually go down to these settings. There are some post-processing things that we won't cover, like if you want to have light shafts and light shaft bloom, which are like post effects for the lights that can make them look more interesting, but some of these effects can also be achieved using the built-in volumetric fog rendering as well. Let's go down to the shadows section. Here we can see that the dynamic shadows are enabled, and they are cast to 400 meters, and the directional light source itself uses the dynamic cascaded shadows. And so the shadows themselves are split up into 4 different shadow cascades, each of which is rendering a larger and larger area. And like the smaller areas are closer to the camera, so we get better quality there. The larger areas are rendered further away. And here are the settings where you can play around and tinker with those settings. Next, let's enable the skylight, which we can see provides the light from the atmosphere. Also, I guess I should enable the visibility of the atmosphere here. While other lights have very similar settings to the directional light, the skylight is a bit more specialized. It is a cube map that is used to gather the lighting from the sky, and this light is then projected all over the scene. So we can get all of this skylight that is by default, if not baked or if not using the advanced lighting features, visible throughout the scene. It is more advanced than just a regular fill light inside an OpenGL context that just has a singular color. So there is more information available when using a skylight. We can see a better view of this if I add in a basic sphere to the scene. So we can see that there are some actual changes to the lighting when it comes to the angle that the surface is facing. Going back to the light source itself, we can choose if it's real-time or not. Right now it is set as a fully real-time light, which means that its mobility as well as the real-time capture settings are on, meaning that whenever the sky changes, and it can be changed by just moving around the direction light. For that you can press Ctrl and L to rotate the light around. And we can see that if we have a very low directional light angle and the sky is purple and yellow and has all of the early morning or far evening colors, we can see that the tonality of the scene fully changes because the skylight updates fully dynamically. Because this scene is supposed to be the baked variant, let's actually untick this real-time capture flag and let's change the mobility of the skylight to be stationary. When you have stationary lights, you can't change their position, or in the case of a directional light, their direction. But you can change their intensity, which can be really beneficial if you want to have some dynamics and somewhat better performance, but it's not ideal when you would want to have a fully dynamic scene. If the light is set as fully static, it would only have a static component, meaning that there won't be any dynamic picture shader calculations active for it, which is the most performant option. And this can be used for all of the lights as well as the geometry. We'll cover what the changes mean very shortly. And there is actually an update that in 5.3 we can use the stationary option with the GPU light baker, but before this you had to use the static option when using the new GPU light breaker due to some limitations that were in place before. So right now, let's leave it as stationary. Let's go back to the directional light source and let's set that to be stationary as well. I'll change the light angle a little bit with Control and L. So maybe something like this looks a bit better. I'll also disable this use temperature option here, because when the sky atmosphere is active and the light source is set to be an atmospheric light that we can see is set here, we don't really have to worry about the color too much if we want to create like a very Earth-like scenario, because the light is simulating moving through the different layers of atmosphere and actually scattering here, and so we already get the tonality from that. Now let's take a quick look at the geometry setting as well. By default, if you drag in a new static mesh actor into the scene, its mobility will be set to static, which means that you can't change it during runtime. For meshes and other actual visible geometry, you don't want to use the stationary option. You only care about the static and movable option when it comes to their mobility settings. You can see what these different settings means by hovering over them. And when it comes to like static scene geometry that doesn't have to move during gameplay, you want to keep them as static and have as many static objects as possible, because they will be a little bit faster for rendering, as well as they will be baked inside the light map, and they will get higher quality lighting due to that. If you have dynamic objects that do need to change their position during gameplay, for example, let's say that this sphere should move, then you would set them to be movable. We'll take a quick look at what this difference means very shortly. For that, let's keep in this object here. Let's actually change the light angle a little bit, so maybe it's somewhat in the shadow. And let's add a copy of this, and let's turn the bottom one to be static so we can play around with the differences after we have baked the lighting. Before we get to baking the lighting, let's take a look at the sky atmosphere. The sky atmosphere provides the color in the sky. It also interacts with the different systems, including the clouds and the directional light, as we already showed, as well as the skylight. Here we have a bunch of settings. We can change the radius of the planet. This actually matters because the atmosphere itself depicts all of this space to actually represent the planet. So if I move this down and move further and further away, we can actually see that essentially the shape of the planet is modeled when you're using the sky atmosphere. I'll press F here to recenter my view and reset the radius. By default here, the settings comply with very Earth-like settings. You might want to play around with the Rayleigh and Mie scattering to see the different kinds of effects that these can have. So if you wanted to model different kinds of atmosphere, for example, the atmosphere of Mars, you can play around with these settings and try to get like different results. Because the atmosphere is also based on a physicalized model, these settings do have an actual basis in physical models when it comes to setting up your atmosphere lighting. There are also other settings when it comes to the cloud. You can define the height of the cloud layer, so how low does it begin and how high the cloud layer itself actually is. And the last element that we added in was the exponential height fog, which can be used to add fog to the scene. Here we can change the color of the fog or add extra color to the fog using the fog in-scattering color, as well as the directional in-scattering color that can be used more as artistic controls. But if the exponential height fog is being affected by the atmosphere, which we can check by going into project settings and searching for sky, we can see that in this project these flags are all ticked. If I move around the directional light, we can see that the fog's color is also being affected by all of the atmospherics. When it comes to the fog, you probably mostly care about how dense it looks, which can be controlled by the fog density slider. By default, it's capped at 0.05, but you can have higher densities if you would like. You can also change its fall off when it comes to the vertical height, and the lower of the exponent of the fall off is, and so the fog itself also can appear higher. You can also have a secondary layer of the same fog that you can have different settings, so you can have like a more dense low-lying fog and lighter fog that affects the whole atmosphere. And the second thing is if you do want to have volumetric fog or not. So volumetric fog is a special effect that is using this Froxel setup to trace the fog inside the screen space and has like proper volumetric scattering as opposed to the bloom and light shaft effects that were present inside the directional light. So let me increase the density a little bit so we can see it a bit better. You also have some extra settings here inside the volumetric fog section where you can define the scattering distribution, which defines how the light moves inside the fog. So if it's mostly scattering forward or backwards, this changes how the fog looks when looking at or looking away from the directional light source. I leave these as default. I'll go back to the density and reset those settings there. And I think this is actually good for the base setup for this exterior lighting. So to see how the scene will actually end up looking when the lighting is baked, let's first add in the last element that is specifically needed for the baked lighting setup. For that, I'll go into the Place Actors menu here and add in light mass importance volume. This defines the area where the quality of the lighting is the highest, as well as where to place the volumetric light samples. What those are, we will see very shortly. This light mass importance volume is a brush volume, and we can change the size of it. So let's try something like 128 by 128 by 64 meters to see if this covers the area that we care about. Maybe this is actually a bit much. When it comes to this, we can also just use scaling, although it might not be the nicest option. It should do for the basic setup. I'll make it a bit smaller to make the light bake go just a little bit faster. So now with the setup, let's very briefly cover the two options when it comes to baking lighting inside our Unreal Engine. We can use the old school light mass system, which is the CPU light baker. We can do that from going into build lighting only. And we can change the quality of this inside the quality level section here. And there are some additional options for this inside world settings, inside the light mass section. But most of these do not apply with the GPU light baker. We will later on create a dynamic version of the level. In there, we will enable this force no peak computer lighting flag. This is the only place in this specific setup where we will be using the CPU light baker because you need to build lighting once if you want to disable all the pre-baked lighting. If you know that you only have one specific type of lighting in your project, so like fully dynamic or using baked options, you can also disable the ability to have baked lighting at all. This will also make the compilation of shaders faster because you will have less variants of shaders to build when you are making your materials. The second newer option when it comes to building lighting is the GPU light baker or GPU light mass, which we can access when going from the build menu and opening the GPU light mass window. I have it also docked in the same section here. This uses the GPU to bake the lighting, and it requires a GPU that does support ray tracing. If your GPU does not support ray tracing, you will need to use the CPU light mapper instead. So for the GPU light baker to work inside your project settings, you need to make sure that ray tracing is enabled. This is the general support hardware ray tracing flag. If you want to use ray traced effects in real time, you also want to have the use hardware ray tracing when available flag ticked as well. If your GPU does not support it, you might want to go into your config beforehand if the project doesn't open, for example, and here go open up the default engine INI file. And in here, you want to set the r.raytracing to false, as well as you might want to change the default graphics RHI to DX11. all of the lab computers as well as the class computers do have ray tracing available. And because the scene is somewhat complex, I will be using the GPU Light Baker to do the baking, because otherwise I would just have to wait longer, even if the lighting quality is set to be preview for the CPU light mapper. Inside the GPU light mask settings, some alterations have been made to the defaults already, just to make sure that the baking happens a bit faster, because again, the scene itself is a bit bigger. The option to show the progress bars is enabled here. To make sure that it works, you need to have the virtual texture support enabled, as well as the virtual texture light maps here. Going back to the scene, let's start the baking process. I'll hit the build lighting button. Here, because the scene is from an older version of the project, it is not using the latest algorithm for generating the UVs. So let's update all of them. Let's make sure we save all the assets with Control Shift and S. And let's now start the baking. By default, this will go slower because the real-time viewport is enabled, meaning that we are updating the frames as fast as we can. But if you want the bake to work faster, what you can do is disable the real-time viewport from this tick box here, or you can also access it from the burger menu inside the viewport itself. If you have this disabled because you have like a frame rate display, this can disable the ability to switch it using the Control and R keyboard shortcuts. You can disable this real-time override, or you can disable the frame rate counter or other real-time elements of the viewport, and so you can use this to speed up the build. If you want to know more about the different kinds of settings and how they affect the scene, I recommend you hover over the different settings and play around with them a little bit. Maybe you want to use a simpler scene though. Here I reduced the GI samples, shadow samples, and the general quality of the irradiance cache for the bake to happen faster. This does affect the quality, so if you want to have a higher quality result, I would recommend to use at least the default settings. This might depend on the scene. For the outside areas, you will get away with lower sample counts, but when it comes to the interiors, you might want to use higher settings because the rays themselves need to travel further distances and do more bounces. But let's get back to the comparison between the dynamic and static objects. For that, let me see which one is which. So the top one is the dynamic object and the bottom one is the static one. To get a better view of the lighting only, I will use the Alt5 and Alt6 viewport view modes. So these are the lighting only and detailed lighting options. Lighting only mostly has only the diffuse lighting for the scene. It does have some extra elements in some cases when it comes to translucent elements or the sky, and in some specific cases also the normal maps. And the detail lighting has the default gray color and normal maps and roughness information on all of the surfaces, so you can get a bit more of an idea. So looking at these two objects, we can see that the shadowing on these are a little bit different. So there is more occlusion thanks to the actual baked light bounces on the static objects down here. And the top one is a bit lighter, although this light blending is quite a bit better than with the old version when it came to lighting the dynamic objects. Unreal Engine 5 and the new versions of Unreal Engine 4 use a volumetric light map. To visualize the volumetric light map and its samples, we can go into Show, Visualize, Volumetric Light Map. You couldn't see that option on the screen, but it was the very bottom option inside the Visualize section here. Here you can see the density of the dynamic light map. So if I move this dynamic object around, the closest volumetric light map samples are gathered and interpolated between, and then applied to this as the diffuse lighting term from the static scene. So if I move it around, we can see that the lighting on the object itself changes depending on if we are outside or inside or in shadow somewhere. And actually the neatest part of this volumetric map implementation is that if I make the object bigger, all of the surfaces or specific pixels on the surface actually consider the closest volumetric light map samples to them, rather than just picking the generally closest ones to the origin of the object, which was true for the older implementation of this. One bug that I will note with this version of Unreal Engine is that the lighting on the landscape actor can be too dark. There is a patch for this, but I expect this to be fixed for newer versions of the engine. And this is not something that you have to worry about when it comes to this course. When it comes to other types of view modes that you can use to debug your lighting and make a decision about your performance, you can use the lighting complexity view, which has the Alt and 7 shortcut, and the Alt and 8 shortcut, which you can use to debug the complexity of your materials. When it comes to material complexity, the redder or whiter the materials are, the more expensive they are, and the more green they are, the cheaper these materials can be. When it comes to lighting, we only have this one directional light that is active right now. But if I added in new local lights, or in this case point lights, which I can add in by just pressing L and left clicking, I can see that adding in a new light means that new lights need to be taken into consideration for each of the pixels that are affected by it. And the more of them they add, we can see this false coloration change, and the more expensive they will become. There is the base pixel shader cost that is here, but if we are using stationary lights, we can only have 4 stationary lights be affecting a single space at a time. If you have too many of them and you build the lighting, you will see a red X next to the light icon, meaning that you have too many lights affecting a single space that we can see here. If this is the case, you want to make sure to try to reduce the number of lights or move them around so that this does not become an issue, or turn them into movable lights, which means that they won't be considered for global illumination, or turn them into static lights, which means that all of their contribution will only be baked and they won't have any real-time cost at all. This also means that their intensity or color can't be changed during runtime. Right now, I will get rid of the lights that I had to the exterior here and add just a few of the lights inside the interior. But before that, let me actually do one change because the light units inside Unreal Engine are mostly physically based. Let me actually go back to the directional light or the sun and change the intensity of this quite high. I will change this to 80,000 lux, which is similar to the intensity of the actual sun during midday in some circumstances, depending on the distance of the Earth from the sun itself and so on. After doing this change, I will go back to the lit view and I will rebuild the lighting. Once this is done, I will disable the visibility of the volumetric light map by toggling the show section here back to defaults. And one last thing before adding in the interior lighting, if we move inside, we can see that the lighting itself adjusts as we move around. So the outside areas get brighter and brighter. And this is to accommodate the difference in the intensity of lighting between the outside and the inside. You might want to have this dynamic effect active, but in other cases you might want to have like one specific lighting intensity to change those settings, as well as all of the color grading. What we can do is we can add in a post-processing volume to affect this. For that, let's go into the visual effects section and let's drag in this post-processing volume here. By default, only the interior of the volume is affected when we change any of the settings. For that, let me change the exposure to be manual and let me compensate it fully down. If I move outside of the volume, I can see that the dynamic effects of the exposure changes are active again. If I move inside, it will use the specific settings set inside the actor to have this volume affect the whole world. What I can do is make sure that the infinite extent attribute is enabled for this. And now I will go back to the exposure section and scroll the exposure back to a value that seems to work for the current setup. Let's say something like -1.5 in my case. And now if I move around the scene, I can see that the interiors are darker. And if I go somewhere into the stairwell here, because so little light affects it, this is much darker still. To light this area up, we can use some of the local light sources. For those, I will go to the light section inside my placement menu. And I'll drag in a point light here that by default has a very low intensity. So let me change the intensity units to lumens and let me change the intensity here to 1600 lumens, which is the intensity of an incandescent bulb that has power rating of 100 watts. So this is something that you can think about when you think about how you set up lighting. And if you want to use physicalized units, you can see actually the range of energy of the lights and the difference between them. So in this case, I'll actually make the light source more powerful, So let's say 16,000 lumens instead. Let me also change its color directly by using the light color option. So if you want to use some specific colors for the lights, for example, if I want to make it green, I can use this here. I can also change the fall off of the light. So for that, let me go into one of the light debug view modes and let me change the attenuation radius. So by default, lights inside Unreal use the inverse square fall off law, meaning that their intensity falls off as it would in the real life. So what this means that I could make the light attenuation radius as large as I want, but only the middle area of this will be affected. So this can be a tool for you to optimize the complexity of the lighting in your scene. So if you make the light smaller, because its intensity is relatively small, you can save up on your GPU resources and add more lights. In this case, I'll turn the radius back to the default, which is 10 meters. And let's also change the source radius, which means the size of the light source. You can think of this as like a large spherical softbox. This affects both the light's specular highlight as well as its shadow handling. So if I move this light behind the railing here, I can see that the shadows become softer and harsher as I change the soft radius. Again, this works because we do have virtual shadow mapping set as the shadow mapping method. If you use regular old shadow maps, we won't see this effect if we don't use ray trace shadows or distance field shadows on the specific light. Let me re-enable virtual shadow maps. Do note that these are quite a bit more expensive, so this can also be a setting that you change depending on what the capability of your computer is, or the target hardware of the users of your application. And let's also add in rectangular area light. Let's also make this much more intense, so we can see a bit better what's going on here. So for this light, you can think of this as a light panel. You can change the size of the light panel as well as its side fall off using this barn door settings. You can change the angle of the barn door as well as the length, and this manipulates how the light falls off on the sides. I'll move this light to the second story here and angle it down like so. Once these changes are made, I will leave these two lights as stationary. So they will actually have specular highlights, but their shadows will be baked as well as their indirect lighting contribution. So let me bake the lighting once again. And now that the lighting bake is done, let's take a look at the lighting itself. Here we can see what the lighting looks like, and we can see like a little bit of bounce lighting here. This is not as visible because we have the exposure turned down. If we want to take a better look, let's disable the post-processing volume just for a second. For that, I will just toggle the eye icon there. And now we can see how the light is actually bouncing around in the scene and how it is mixing. There are some issues that also become apparent with the light maps. These smudges and things will get better if you increase the lighting quality settings in the GPU light mask if you're using that, or from the world settings if you're using the CPU light mask. And another thing that you might want to take a look at is the actual density of the light map. If I press Alt and 0, I open up the light map previewer where each of these squares here represents a single pixel inside the light map. You can manipulate the density of the light map by selecting the object and searching for the light map resolution, which we can override per specific instance of the object. Or what you can do is open up a specific mesh inside the static mesh editor. I'll dock it next to my other windows here. To change the default settings for this specific mesh, I would have to change the build settings for it. And scrolling down here, we have the minimum light map resolution. This defines the density of the UVs, because the UVs of the light maps are usually auto-generated inside the engine. If you are not doing so, you can change the source light map index for that. And you can change the light map resolution itself from the light map resolution section down here. When it comes to different surfaces, you might want to have different densities. If you have a lot of small components or crevices or extrusions and things that would convert to smaller areas having more differences in them, then you might want to have a higher light map density, as you can see from this pipe example. But if you're just dealing with very large flat surfaces, you might want to have lower densities there. Another thing to consider about your light map density is the memory that is available to you. So if you're working with lower end platforms, you might want to use lower densities, or if you want to make larger worlds that have baked lighting, then you might also want to consider smaller light map densities for those. Having the virtual light maps enabled can be a good performance boost when it comes to making larger worlds with higher density light maps. Last thing when it comes to this scene that has the static setup are the reflections. And right now they are not very great, especially if we again disable post-processing volume. We can see that there are these weird highlights. That is because the cube map that is used to light the scene is taken from the skylight. If the skylight is stationary, it also produces a cube map that is used for specular reflections. If we wanted the reflections to look better, we can either use some sort of a real-time option to have better locality there, or we can use reflection capture actors. To better visualize what the reflections actually look like, we can go into the view modes again and choose the reflections option. Here you can see what the reflections themselves look like, and right now the skylight only captures the sky and clouds in it, and the lower hemisphere is black because we are very close to this quote-unquote planet surface. So to get more accurate reflections, let's first off use the most performant option for this baked scene. For that, let's go into the visual effects section and let's drag in a box reflection capture actor. Here you can see that we immediately see the interior scene here. Let's actually set them up a little bit better. So for this section here, we are using the box reflection capture actor because this area roughly resembles a box, even if it's not fully right angled. But let me change the scale of this a little bit. So I will move it up here. And let me try to adjust it just a little bit because the box reflection capture actor actually is using the scale for its size setup by default, but its default size is 1 unit, which is 1 centimeter. This means that if I want to change the values on this specific axis, I would have to drag my mouse up and down a lot. So it might be an idea to try to manually enter some values that are at least a little bit closer to your desired values, so you get a better result quicker that way. Also note that this box reflection capture actor has these 2 boxes visible inside it. Let me go back into the reflections view. The outside surface of these 2 boxes is the area that is fully affected by the skylight in this case, because we don't have any other reflection captures in the scene. And as you move towards the interior of these 2 boxes, you will lerp to being fully affected by the box reflection capture. So let me move it around a little bit more. In this case, I'll say that it is good enough, and I definitely should add in more of these to cover the stairs areas. You can use less of them to have a less precise presentation that uses less memory and might be more performant. But if you want to get better results, you might want to use more of them. I will leave adding in the other versions as an exercise to the viewer, but right now I will add in one more general one so I can get better reflections on the window surfaces. For that, I will add in a sphere reflection capture. I'll drag it in here. I'll go back to the reflections view to show what this surface looks like. There are actually specific projections. So the box reflection capture uses a box as its projection. Let me rebuild it here to make it visible again. This will need to compile some shaders. Once this is done, I'll save the scene. And here, when we move around, we can see that the parallax is shaped like a box for this area here. And it is shaped like a sphere here, although because the surfaces are not completely planar, it's a bit more difficult to see what the projection itself looks like. But I wanted to make this reflection capture actor cover the village section here. So let me make this a bit bigger again. And let me rebuild the reflections so I get a better view here. So now if I go back to the lit view, I get more correct reflections on the window surfaces as well. If you wanted to have higher quality reflections that do have more local information, for example, these windows don't really line up that well, then what you can do is use either screen space reflections or lumen reflections to modify this. You can do this on the project level, or you can modify it per processing volume. So let's go to the post-processing volume and search for reflections. I'll change the method to screen space. I'll go back to reflections view as well. So now if I look around here and point the camera down, we can see more of the cube map reflection. And if I move the camera up, we can see more of the scene is actually reflected inside the screen space. If you are using DirectX 12 and you do have ray tracing enabled, including the use hardware ray tracing when available, then you can also use lumen shadows with baked lighting starting from 5.3. If I change my reflection methods to be lumen, then now the reflections are more accurate, and even if I look down, the lumen scene will be used for calculating the reflections. This is more expensive and again requires a ray tracing capable GPU, but if you want to get higher quality reflections, then it is definitely a good option to use that. Also, if you use that, you wouldn't really need to fall back to the reflection capture actors, but it might still be an idea to have like a somewhat of a coarse representation, because lumen reflections do have a limited range. And that's pretty much it when it comes to the baked setup for the scene. So let me save everything here again, and let's very quickly convert this to a dynamic scene. For that, I will make a copy of the map. I'll do that from the content drawer, Control D to duplicate the asset, and change the name to demonstration RT for real-time lighting. And let's also save it, open it up and search for all the lights. We don't need the light mass importance volume here. And I will select my directional light, change it to movable, and I'll do the same for all the rest of the lights. I will also, in my skylight, change the capture method to real-time capture. This means again that skylight is updated in real time, and this will also work during runtime or in game or in build projects. So we'll get better results using this. I'll save the scene again. And one thing that I also wanted to show here is that if you create a new object in the scene, let me grab a cube. I'll create the material inside a new folder called materials. I'll make the new material, call it mHello, and inside the material I will add a parameter to make it emissive, and I will change the emissive intensity to, let's say, 16,000 again. Let's make it red, for example, and let's save it and apply it to our cube. Maybe make it even more intense so that the effect is more visible. Let's actually multiply this by 10. So now if I go into my lighting preview modes, I can see that I actually would need to build the lighting. Let me do that. I will go into my world settings, disable the pre-computed lighting, so no light maps will be applied to the scene. I will go into build lighting only, save the scene, and go back to the lit view, and find that the scene doesn't look quite right. That is because I also need to enable lumen global illumination, but because we want to do it per scene, let's do it inside the post-processing volume. So for global illumination, let's enable lumen. The default is set to none. So now we can see that the emissive material of the cube actually lights up the whole scene, and it affects both the diffuse global illumination, and because we had the reflections also enabled, it will also affect the reflection lighting for the scene as well. And the nice thing about this is that if you already have lumen enabled, you essentially pay nothing for using these emissive surfaces as light sources. So this can be an interesting idea to optimize your real-time lit scenes. But do keep in mind that if you make the light sources very small, or the geometry that emits light very small, you will end up with a very noisy result, because the lumen scene that we can visualize under view mode lumen overview, we can see that the resolution of the scene inside this lumen view is somewhat limited, so to keep that in mind. And one last thing, or two last things that I want to show is that if you do have ray tracing enabled and you can use it to preview the scene in a path traced way. You can enable the path tracing view mode from the view mode selection in the viewport. This will trace rays into the scene and produce a path traced output. This is the highest quality output when it comes to the scene lighting quality, but it does not support all of the lighting features, as well as it is not performant enough to be really used in real time. So this can be mostly used as a ground truth comparison for your scene between what the path traced view looks like and what the default lit or lumen scene looks like. And the last thing I want to talk about is profiling your performance. There are various different stat commands that are available for you that you can access from this program menu inside the viewport or by entering them manually into the console. So one interesting thing here is stat GPU, which you can use to display the various real-time stats. If you want to get a more extensive overview, you can also use the GPU visualizer, which you can capture single frames with by pressing Ctrl, Shift, and comma. And here you can break down the contents of the scene and see what are the specific steps and things that take up most of your time. In this case, there is quite a large global illumination cost, as well as we pay quite a bit for post-processing. Most of this will be the temporal super resolution, or TSR AA. Another stat command that might be interesting, let me remove the stat GPU, is stat RHI. Here you can see the stats for the scene when it comes to specific elements that are visible. So how many triangles you draw, how many draw calls you send to the GPU, what is your memory budget, and that's pretty much it for this. You can also obviously show frame rate. Ctrl Shift H is the shortcut for this. If you want to get a bit more information, you can use stat unit for that. So you get a better idea of how much time you're spending on your game code, or how much of your time you're spending on the CPU render thread, or how much of your time is actually your GPU rendering time. And obviously all of these commands work in game. That's it for this video. Thank you for watching.